Hello, my name is Tomas Diaz. Today I decided to do a genetic algorithm in C++ with neural networks to try to have multiple creatures attempt to go from one location to another in a map while climbing mountains in a topographic map. For this, I extracted a section of the Dolomites in Italy just because they look cool and extracted the height information in a map, and then from there extracted all those points and converted it into a topographic map. I created a header file to load the information from a CSV file of all of those heights, another header file to do the interpolation for the heights at any XY, and then inside that header file, the grade to calculate the grade at a different position and at a different direction, and also to calculate a grade ahead, as in like when you're looking ahead at a certain radius at a certain direction. Then another header file to define the neurons, the number of sensors, and number of actuators for my neural network. For the sensors, we're going to have the creatures look at a specific radius in front of them at multiple locations at different angles, and at twice that radius also at multiple locations. And at this point, the creature is going to measure the grade. The creatures are also going to measure the distance to the target, the difference in height, and the relative bearing to that target. For the actuator, we're only going to have one actuator, which is the change in direction. As a result of this change in direction, a new grade will be calculated, and then with this grade, the speed will be given by this curve with the maximum speed at a grade of minus 5%. This is how our neural network looks like with 19 sensors, 30 neurons in one hidden layer, and one actuator. So we have our grade points on the sensors, we have our previous displacement and speed, we have the relative bearing, we have the difference in heights, we have the distance to target from the topo map, and we have the one actuator which will provide the change in direction, which will provide the new grade, which will provide the speed for the next time step. Here is the best path for the best creature for each generation. Here I'm showing the animation of 200 creatures for each generation for 50 hours of simulation time each. With the genetic algorithm at the end of each generation, the code sorts the creature based on performance. We then kill the lower performers, including those who go around in loops or those who go out of bounds from the map. The top performers move on to the next generation, with some variation and some of them with some mutations. With each generation, the creatures get better and better, more fit. The last generation will have the fastest creature reaching the top at like 3.5 hours or so. Whereas in the first generation, they were all over the place and they were going in loops, going to the different peaks and going out of bounds and everything. So I did this for fun, and it was beautiful to see um, how these creatures, based on the code, they interact with the map, and then they try to reach their goal, and we go through the multiple generations until we get a better generation. We can see how most of the creatures are following a similar path and how they are going around the topo line. We still have some other creatures that go elsewhere or try to go to different peaks or get stuck going around in circles in the same topo line. But it's fascinating to see how they look for the topo line because they can't climb up too fast. So they kind of look around and sometimes loop around the different topo lines and try to find path to the target. Very fascinating to see how they all behave just with the neural networks. It's fascinating to see this. I like it a lot. The one drawback, however, is that now these creatures at the final generation are good from this particular starting point to this particular target point in this particular map. If I put these creatures on a different map or from a different target point, then they gotta be retrained and like we have to go and mutate again and perform a new path and so on. I know there are better methods to determine shortest path, like using variational calculus and stuff, but I just wanted to do this one because I wanted to include the animation and see the animation on this and then generate the CSV files with all the points and everything else on each of the generations. I wanted to include the how these behave and like integrate, have the code save all these frames and have the code generate all these animations. And I just wanted to see essentially my creatures, the creatures that I created here, trying to do and go from one point to the other and climb these in the fastest time possible. And that's it. I had a lot of fun doing this. It was very interesting, and it was just a fun exercise in neural networks, and it's also a fun exercise in genetic algorithm. I hope you like it, just like I did. Thank you.